Hi, welcome to EC&M Tech Talks. You know, probably if we do installation type work, probably the most common circuit that we install out there is a branch circuit. If we do maintenance work for a living, and service calls and so forth, we often get requests to maybe troubleshoot a problem on a branch circuit or extend a branch circuit. In other words, hey, I need a receptacle on that wall over there, or something like that. And we certainly run into that. So anyway, that's the topic of today's talk. It's going to be on Article 210, which is branch circuits not over 1,000 volts AC or 1,500 volts DC. Now, if you need to go over 1,000 volts AC or 1,500 volts DC on a branch circuit, service and feeders, you need to go to Article 235. But we're sticking with Article 210 today for circuits not over 1,000 volts. So most commonly what? Our 120 circuits is probably what we're talking about. Motor circuits, 480 and so forth. Anyway, there are 4 sections that we're going to be talking about. First section is just some general information, sizing of conductors, ratings, definitions, different types of branch circuits, and so on. The second topic we want to get into is going to be our ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, AFCIs. The third topic we want to talk about is branch circuits, specifically where we have to put them, and we're going to see most of those requirements in dwelling units. So we'll be talking about that. And then finally, we really want to summarize everything up. There's a lot of information in Article 210. Once again, typical tech talk, more than we can go through in the time allotted for our EC&M Tech Talk. So I'm going to sum some things up for you in the 4th section and show you some tables that are in Article 210 that you can use. So let's move into Section 1. I'm going to be using my National Electrical Code. My most current edition is the 2023, and so that's where I'll be going for information. First thing let's do is make sure we're all on the same page and understand these different types of branch circuits. Let's first look at the definitions in Article 100 as to just what a branch circuit is, and then the different types. And you'll find them under branch circuits in Article 100, and then branch circuit, comma, appliance, branch circuit, comma, individual, all that. So anyway, let's just talk about what a branch circuit is. Here I've got my panel board, and I've got a 20 amp circuit breaker up here, and through some number 12 wire, the ungrounded conductor, the black wire, right, is supplying an outlet over here to which I have nothing connected yet, but I could certainly connect a receptacle here. And then the white wire runs from my grounded bus bar inside of my panel board and through that same conduit and comes out here ready to connect to something. And then of course I have my equipment grounding conductor, the conductor with the green insulation on it, and that runs from my grounding bus bar, equipment grounding bus bar on my panel board, out to my metal box, which I have gone ahead and bonded that to my metal box, and I'm using some EMT, electrical metallic tubing today. Now, some things. First of all, the size of the branch circuit. This is number 12 THHN. So we know it will carry more than 20 amps. We can look that up in 310.16, can't we? However, Article 210 tells me that, hey, the size of this branch circuit is whatever size that overcurrent protector device is. So, some terminology then. The branch circuit is the conductors. It doesn't say that the branch circuit includes the overcurrent device. The branch circuit is the conductors that run from my overcurrent protection in the circuit out to where I'm going to utilize the electricity. Final overcurrent protected device, the conductors from the final overcurrent protected device out to where I'm going to plug or attach something out here and eventually utilize that electricity with some utilization equipment. The size of the branch circuit, whatever my overcurrent device is designed to protect that. This is a 20 amp branch circuit, 20 amp circuit breaker, so it's a 20 amp branch circuit. Here's another example. This would be for a motor over here. Let's say if I were supplying a motor with these fuses. Now the fuses in the circuit breaker, remember, supply short circuit and ground fault protection. Short circuit and ground fault protection supplied by fuses and circuit breakers, and that's covered in Article 240. So we are going to have to reference back to 240 here in a little bit. But anyway, so inside of this disconnect switch, I have some 30 amp fuses, one for each phase, A, B, and C, 30 amp fuses. So the size of this branch circuit would be 30 amps. And if it's supplying a motor, then it's called a motor branch circuit. The conductors that come into the top of my disconnect switch, probably coming from a switchboard or maybe a motor control center or whatever it is, those are called feeder conductors. Feeders, and that's a separate article, isn't it? Separate article in Chapter 2. But the branch circuit runs from my final overcurrent protective device out to my motor out here, whatever motor I've got coming off of these 30 amp fuses. Now, it's also important to understand when I talk about a motor branch circuit, I'm also including, I'm also including my motor starter. So any accessories that I would have from the bottom of these conductors, or from the bottom of these fuses, through the conductors, through this motor starter and out to my motor, that's all my branch circuit then. And it's a 30 amp branch circuit because I have 30 amp fuses. Overload protection, we know, is supplied by the overload in the motor starter. And of course, that is Article 430. So, we have motor branch circuits, we have branch circuits, we have general purpose branch circuits. A general purpose branch circuit is where I just have two or more receptacles attached to my branch circuit. This is an example. This is two receptacles. Each half of this duplex receptacle is one receptacle. Each half of this duplex receptacle is rated for 20 amps. So each one of my receptacles is rated for 20 amps. And they all sit on one strap or yoke, don't they, on the back side. They're all attached. The equipment grounded conductors on both of these receptacles is attached to that metal yoke. Now, so by definition, if I just had one of these attached on this particular branch circuit that I have, I could call that a general purpose branch circuit because I have two receptacles. Generally, we run a lot more than that, don't we? In fact, we might have some lighting coming off of that one branch circuit. We may have some general purpose receptacles. We might even have an appliance. It's still called a general purpose branch circuit. Now, I can also have an individual branch circuit defined in Article 100. And an individual branch circuit just simply means that I only supply one piece of utilization equipment with that particular branch circuit. I can also have an appliance branch circuit where I have one or more appliances attached to my branch circuit, but I don't have any luminaires attached to it. And then I have the multiwire branch circuit. Maybe not as common as it used to be, but on the multiwire branch circuit, I'm going to go to the ungrounded side on this receptacle and break off that little tab and separate out my two receptacles, right? So by definition, what I've got on a multiwire branch circuit, I'll take and I'll run one conductor off of one circuit breaker to this, say, the receptacle on your left, okay? And then I'll run another wire to my receptacle on your right. There's going to be a voltage between those two sides of that receptacle, isn't there? The red and the black wire, most likely, in a dwelling unit application. And between that red and the black, I'm going to get 240 volts. So I have a line-to-line voltage difference there. And where I connect my neutral on the other side, if I read from any line to neutral, I get my 120 volts, or I have a difference in potential, don't I, from line to neutral. So by definition, that's the multi-wire branch circuit. And we're going to see there are some specific requirements for multi-wire branch circuits in Article 210 as well. Some of the other general information, though, that we need to be aware of, and we've seen this in the 2023 code, Section .2 now in our different articles. Section .2 tells us what we can recondition and what we can. Well, guess what? Article 210, Section .2 tells me that I cannot recondition AFCIs and GFCIs. Now, recondition, we can go look back in Article 100 and find a definition for recondition, and it's different. It's if I'm going to rebuild something, I recondition it, as opposed to doing routine maintenance on it. Obviously, I'm not going to try and rebuild a GFCI or AFCI, so we're not allowed to recondition those. Table 210.3 right at the front of Article 210 is might be very beneficial for you. It lists about 9 or 10 different specific applications for other branch circuits, other equipment. For instance, if I had a question about motors, it's going to reference me to Article 430. If I had a question about a branch circuit for a piece of HVAC equipment, it's going to reference Article 440 and may well give me the specific sections where I would go to find information on those branch circuits. Now, also very important for you to understand the index, okay? Always use your index. If I go back to the index at the back of my code book, I'm going to find probably about 60 or 70 different references to different applications and different types of equipment, all related to branch circuits. So go to your index, look under branch circuits, and you find a whole list, a couple columns long, actually references to other applications of branch circuits. Now, I mentioned the multiwire branch circuit where we break that tab on the hot side, and we have two separate conductors coming in, one to each half of that duplex, and I have a voltage between those two conductors. Now, some of the requirements in 210.4 for our multi-wire branch circuits is, first of all, they have to originate from the same enclosure. Okay, that makes sense, doesn't it? I've run into that in three-phase systems, and probably some of you have as well in single-phase or three-phase systems. I had an instance where probably an inexperienced person, probably not an electrician, whatever, I was working on an injection molding machine, and I had power coming in, right? I had power from A phase and C phase from one panel board and power from B phase from another panel board. Well, that gets into another whole separate list of issues there and whatnot in the code. But anyway, I always want to originate my conductors, obviously, from the same enclosure. I have to group those conductors. So if this was, it's not, but if this were a multi-wire branch circuit, I would want to take probably my red and my black and my white, and I would tie them together. I could label them, whatever. Maybe it'd be easier, I'd just take a cable tie and put on those three conductors, and that way they're grouped together. If there is an exception, okay, it's pretty obvious. For instance, if I were, well, let's take this one. Let's say I were using this type MC cable in order to supply this outlet. And let's say it were a multi-wire circuit, whatever. It's pretty obvious, right, when I attach this MC cable to my enclosure up here for my panel board, it's going to be obvious where all those conductors are coming from. So I would know that those conductors are coming together. So when I come from all my conductors are in the same cable or same conduit, I don't have to group them together by putting that cable tie or cable marking or whatever. So anyway, an exception for that. I have to have a disconnecting means, right, which I would have. So let's say this were for a 20 amp branch circuit, and I've got two separate circuit breakers. So I have two circuit breakers here that would plug onto my panel board. Now what I've got on here, though, it references me, 210.4 tells me, it says, hey, go look in 240.15b. So I go to Article 240 on overcurrent protection. Subsection B, 15b is going to tell me that I have to use identified handle ties, because my requirement in 210.4 is I have to open and close all those conductors at the same time. And so this is identified for use. Okay, and how do I know that? Well, because when you buy this to put it on there, you buy the breakers joined together, whatever, that's what it comes with, and it's from that particular manufacturer. And it also tells me on here, it says common trip. So if I were to look on the wherever I bought this from, okay, it would tell me that those are handle ties for use with this particular type breaker. Now, so that's found in 240.15b once again. 210.5 says, okay, we have to identify the conductors in a branch circuit. So for the grounded conductors, in other words, in this case, our neutral, right, it's going to refer us back to 200.6. 200.6 tells me that, hey, the grounded conductors, they either have to be, and there's several options there, but basically they're going to be white or gray in color. They may be have 3 white stripes on it, and on some other color other than green and so forth. But white and gray is typically what we're going to use in a branch circuit. Now, on the way that we often see that is maybe in a 3-phase system. So we have a 480 volt 3-phase system. So for the grounded conductor, we'll probably use gray. And then for the ungrounded conductors, we might use brown, orange, and yellow. Now the brown, orange, and yellow, not required by the code. That's just pretty common out there in the field. If it's a 208 volt system now, so now we've got 208 volts phase to phase and 120 from phase to ground, we'll probably go ahead and use that white covered conductor for our grounded or neutral conductor. And then the phase conductors, once again, as long as they're not green, because we know that's reserved, Article 250.118 tells us that the equipment grounding conductor can be bare copper or green or green with 2 or more yellow stripes on it. Single phase system, we're going to use white for our grounded conductor, and for our ungrounded conductors, we're probably going to use black, red, and then our equipment grounding conductor, once again, 250.118 talks about bare copper or green insulation on it, or green with the yellow stripes. So anyway, that's all covered in 210.5 then. 210.6 gives us specific voltage limitations. And that's by depending upon the occupancy and any specific applications that we have. For example, in a home, in a dwelling unit, we're not allowed to use anything above really 120 volts for lighting. I can't have 277 volt lighting, however I would get that. I can't have that in my dwelling unit. I have worked overseas where I've seen 3-phase power and 277 lighting in a very nice home. But anyway, that wouldn't apply here in the United States, would it? So we have to pay attention to 210.6 and make sure that we use the right voltage levels to supply our loads. Now, generally not a problem in our dwelling units and multifamily dwellings. We got to take a look at commercial industrial establishments other than dwelling units, make sure that we're always in compliance there. We're using the right type lamp holders for the higher voltages and things like that. Let's move on to the next section now. Section number 2 we're going to address ground fault circuit interrupters and arc fault circuit interrupters, so GFCIs and AFCIs. First of all, let's take a look at ground fault circuit interrupters. And to do that, I'm headed to my code book because I can't remember all this stuff. But as far as 210.8 is concerned, it's divided up into 6 different sections. And so subsection A, 210.8A, addresses the GFCI requirements for dwelling units. And there are 12 requirements for dwelling units. Section B, subsection B in 210.8, addresses other than dwelling units. And there are 15 requirements for other than dwelling units for GFCIs. Subsection C talks about lighting outlets in a crawl space. Very simple, I think it's 1 sentence long. It says we got to have GFCI protection on a lighting outlet in a crawl space. That is because for safety, right? If we're crawling around down there in the crawl space, we don't want to bump in with our back or head or something, bump into that luminaire and end up getting a shock or something worse yet happen to us. So required to be GFCI protected then. Specific appliances must also be GFCI protected. That's covered in subsection D in 210.8. Subsection E talks about equipment requiring services. And that's going to refer us to 210.63. 210.63 says, hey, look, we have some HVAC equipment out there, and so maybe on a rooftop unit, you need to supply a receptacle for that service technician. That receptacle has to be on the same level and within 25 feet of that equipment. That's what 210.63 says. Then 210.8 says, oh, and by the way, you have to GFCI protect that receptacle as well. And there are some other requirements for equipment requiring servicing in subsection E. And then outdoor outlets, no surprise to us, outdoor outlets have to be GFCI protected. Now the way that the GFCI works, right, if we think about a lot of these rules, try and get a handle on them, the way that the GFCI works is it watches how much current goes out on the ungrounded conductor, say the black wire in this case, and how much current returns back on the white neutral wire. And remember, the breaker doesn't trip till, well, over 20 amps if that's a 20 amp breaker. So that breaker's not going to protect me. I'm going to be shocked and electrocuted in milliamps of current flow, thousands of an amp of current flow. So by the time the breaker trips, it's all over for me. So what the GFCI does, if it sees a mismatch of 4 to 6 milliamps, 4 to 6 thousandths of an amp, it will go ahead and trip. So if it sees X number of current coming out on the ungrounded conductor, and it sees 4 to 6 milliamps less coming back in on the neutral, boom, the GFCI trips in a fraction of a second and protects me then. The problem we run into out in the field sometime, isn't it? Hey man, especially in construction, we need to bypass that GFCI. It keeps tripping on me. Well, maybe because we've got these power cords or welding outlets or whatever they are out here. We've got stuff laying out in the mud and the snow and whatever it is. And gee, maybe the GFCI is just doing what it's supposed to be doing, huh? So anytime we get a GFCI trip, we need to investigate and make sure why it's tripping then. If we take a look at the dwelling unit requirements then, 210.8A, we see our 12 different requirements in. We'll just go through them very quickly. Bathrooms, garages, and also talks about accessory building. But basically bathrooms, garages, outdoors, crawl spaces, so receptacles and lighting outlets in crawl spaces, basements, kitchens, areas with sinks and permanent provisions for food preparation, so forth. Sinks within that 6 foot from the top outside edge of the sink, the top inside edge of the bowl of the sink. If that receptacle is within 6 feet of the top inside edge of the bowl of that sink, it must be GFCI protected. Boat houses, probably a good idea for a GFCI there. Bathtubs or shower stalls. Oh, but it says where receptacles are installed within 6 feet of the outside edge of the bathtub or shower stall. So we've installed one within 6 feet of that shower. Laundry areas are required to have GFCI protection. A lot of water there, that makes sense. And then indoor damp and wet locations require GFCI protection. So damp, wet locations all defined in back in Article 100 for us. And then there are some exceptions. We won't go through all the exceptions. If you get involved in installing, replacing GFCIs, make sure you follow for dwelling units 210.8A. For other than dwelling units, there are 15 requirements. A lot of similarities: bathrooms, kitchens, areas with sinks, buffet serving areas, rooftops, outdoors, sinks where receptacles are installed within 6 feet from the top inside edge of the bowl of the sink, indoor damp, wet locations. Locker rooms was added a couple editions ago, which makes sense. A lot of people in there, wet areas and so forth. Garages, accessory buildings, crawl spaces, unfinished areas of basements. And here's an addition for the 2023 NEC. It says aquariums, bait wells, and similar open aquatic vessels or containers, such as tanks or bowls, where receptacles are installed within 6 feet from the top inside edge or rim or conductive support framing of the vessel. Also, laundry areas and bathtubs and shower stalls. That's 6 foot requirement then. So pay attention to your GFCI requirements then, whether you are doing new installation work, replacing receptacles, remodelings, whatever it is. Make sure you follow 210.8 for GFCIs. Now, for AFCIs, arc fault circuit interrupters, they work a little bit different than GFCIs. The AFCI actually senses an arcing condition. Maybe not even one that you can physically see, but there's some current tracking from one conductor to another. It could be in series along the conductor and parallel to another conductor. And we call that a AFCI that would detect both of those types of faults. We call that a combination type AFCI. So don't get screwed up here and think, oh, a combination AFCI also includes a GFCI. I've heard that misconception used out there in the field, and don't do that. So anyway, 210.12 talks about where they are required. And if you go through and you read 210.12, you're going to find in dwelling units, okay? So first we take a look at the requirements for dwelling units. And what we're going to find is a list of, 14 different items. Kitchens, family rooms, dining rooms, living rooms, parlors, dens, bedrooms, sunrooms, and on it goes. In fact, the only rooms that I can just kind of come up with, areas that are not required to be AFCI protected, I don't see any requirement for bathrooms, and I don't see any requirements for garages. Oh, but they're covered by 210.8, aren't they, for GFCI protection. So if you really look at the requirements now in a dwelling unit, all receptacles are going to be either GFCI protected or AFCI protected, which is pretty much what it boils down to. Subsection C in 210.12 covers dormitory units and where we have to have AFCI protection in dormitory units. Because remember, we're preventing fires. And so we want to prevent fires certainly in dwelling units. We want to prevent fires where people are sleeping in dormitory units. Section D talks about other occupancies, 210.12D, hotels, patient sleeping rooms, and sleeping quarters, and fire stations, and police departments, or whatever. Right? So they have to have AFCI protection. Let's move into Section 3 now, where we talk about where branch circuits are required. 210.11C talks about the requirements for branch circuits in dwelling units. And it says I have to have 2 or more 20 amp small appliance branch circuits in kitchens. Now, we're going to find for all of these requirements in 210.11, we're going to find more specific information in 210.52, such as location, maybe along wall spaces and countertops and all that. But anyway, 210.11 says I have to have 2 or more 20 amp small appliance branch circuits in kitchens. I have to have at least one 20 amp branch circuit in my laundry with no other outlets on it. I have to have at least 1 or more 20 amp branch circuit for bathrooms. And at least 20 amp branch circuit for my garage. Then 210.53G, okay, talks about my requirements for having receptacles in each bay in my garage. But that's another issue. So those are my minimum requirements in dwelling units then for branch circuits. Let's take a look then at 210.52B and find out where these dwelling unit receptacle outlets, some more specifics about where they have to be located and so forth. Now, this is a large section, and I'm not going to get into all the details on it. Small appliances. We saw the requirement for small appliances in 210.11, branch circuits for small appliances. Section B gives me more detail. Countertops and work surfaces is covered in subsection C. Bathrooms is covered in subsection D. Outdoor outlets in E. Laundry area in F. Basements, garages, and accessory buildings in subsection G of 210.52. And hallways in subsection H. And then finally, our entrance foyers is covered in subsection I. That's a lot of information. And those are for dwelling units. Now notice what it says about receptacles in other than dwelling units. Nothing really. Well, what about lighting outlets? Well, yeah, there's plenty of requirements for lighting outlets in Article 210. If we were to take a look at 210.70, we find our requirements for lighting outlets. Well, take a look at 210.11 and 210.52 then, if you get involved in installing receptacle outlets in dwelling units. Now, 210.65 talks about receptacle requirements in meeting rooms. So that's other than dwelling unit. In a meeting room, maybe in a hotel or somewhere. It also talks about where those receptacles have to be placed along the wall. And also we have floor-mounted receptacles in meeting rooms. It addresses that as well. 210.70 then covers lighting outlets. Where they're required. Several requirements for dwelling units in 210.70. Guest rooms and suites in hotels must have lighting outlets. And for all occupancies in attics, underfloor spaces, utility rooms, basements, they have to have lighting outlets. Not specific really though on other than dwelling units, other than that attics and underfloor spaces and so on. Yet lots of requirements for lighting outlets in hallways and living areas, all of this, and kitchens and what and not, in my dwelling unit. The reason is, what am I building? If I'm building a dwelling unit, I know I got to protect people there. But am I building a warehouse or am I building an oil refinery? Oh, probably a big difference on branch circuit requirements then. So that's just going to be according to design of whatever it is we're building as to where we're going to require our receptacle outlets and our lighting outlets in other than dwelling units. Now, let's move to the final section, section 4, and kind of sum a lot of this information up about the tables that we're going to need. When it comes to sizing our conductors, according to Article 210, what size conductor I need for whatever branch circuit I'm going to supply. The general rule, and we see this throughout the code and other applications as well, is we must size our conductors to carry 100% of the non-continuous load and 125% of the continuous load. And that makes sense. If I'm going to have something, and by definition, I'm going to have something operating for 3 hours or more, say at full load, it's continuous load, it'd probably be a good idea to go ahead and make my conductors a little bit bigger than I need them. So I'll size them at 125% of those values. Now, but if we look at the tables when it comes to branch circuit, we can solve a lot of problems for us. And the first table I want to mention is 210.21b2. Maximum cord and plug connected load to receptacles. Pretty simple and short little table. On the left-hand side, it gives me my circuit rating in amperes, 15 or 20 amp circuit, for example. The receptacle rating I can use on a 15 or 20 amp circuit then would be 15 amps, and the maximum load in amperes is 12%. That 12% is based on 80% loading on that overcurrent protective device. So 80% of 15 amps would be 12. 80% of 20 amps would be 16. And then 80% of 30 amps would be 24 amps and so forth. So that's what that little table is based on. Pretty well straightforward. A 20 amp circuit, so a 20 amp branch circuit like we have up behind me. It says the receptacle rating in amperes would be 20 amps, and the maximum load then would be 16 amps. By design, cord and plug connected equipment then. The next table, let's take a look at 210.21b3. Receptacle ratings for circuits serving more than one receptacle or receptacle outlet. So this is more than one receptacle. This is 2 receptacles on there we talked about and so forth. But typically I'm going to have a string of receptacles out here, right? So table 210.21b3, receptacle ratings for circuits serving more than one receptacle or receptacle outlet. And sometime this should clear up a little bit of confusion, some questions that people have. The circuit rating, if it's a 15 amp circuit, 15 amp circuit breaker, for example, my receptacle rating would be 15 amps. If it's a 20 amp branch circuit like we have up here, I can install either a 15 or 20 amp receptacle on that 20 amp branch circuit. 30 amp receptacle, and then it shows 40 amp circuit breaker. I could use a 40 amp receptacle, 40 or 50 amp, and for a 50 amp circuit rating, I can use a 50 amp outlet receptacle then. Then the final 2 tables are on the very next page if you're in your 2023 edition of the code book. Table 210.24, number 1, and then table number 2 right below it. Summary of branch circuit requirements. Copper conductors is table number 1. Table number 2 is aluminum and copper clad aluminum. Let's take a look and see how we can decipher this table. Let's use the first table then for branch circuits requirements for copper conductors. It says if I have a circuit rating, if my branch circuit is rating for 10 amps, yes, I can have a 10 amp branch circuit now, okay? So, and I'm limited as to what I can put on it, as we'll see. And it's going to tell us that in this table. So if I have a 10 amp branch circuit, my conductor minimum size is number 14 AWG. Any taps I take off of that, 14 AWG. Overcurrent protection, we know that's 10 amps because it's a 10 amp branch circuit. Outlet devices, lamp holders permitted, any type. Receptacle rating, oh, not applicable. I'm not going to put a receptacle on a 10 amp branch circuit. Maximum load, 10 amps. Now take a look at the bottom. It says permissible load, and it references 210.23a. And if we go look at that, it tells us where we're going to use a 10 amp branch circuit. Maybe an exhaust for a bathroom fan, in a bathroom, okay? Something like that. Or some lighting that's part of an appliance or whatever. So, anyway, that's covered. A fireplace, another good example where we may see now 10 amp branch circuits. So we have to supply that pilot light and maybe a fan, something like that. And then you just read on over 15, 20, 30 amp branch circuits. And our 20 amp branch circuit up here, it says minimum conductor size is going to be a number 12, which is what we have installed. Can I go larger? Absolutely. Why would I do that? Well, I have to see what the largest size is I could put on that, and it's probably a number 10, is it? I don't know, I need to look at that 20 amp receptacle. But anyway, I can go up to a larger size on that for voltage drop. So if I had a really long run, and that's found as an informational note in Article 210. I don't want any more of a 3% voltage drop from my feeder down to my overcurrent device, or no more than 5% total from my feeder on out to my branch circuit. So anyway, that's an informational note. You'll see that. So back to my 20 amp branch circuit, minimum number 12 wires. Any taps can be number 14. Fixture wires and cords, it refers me to Article 240 on overcurrent protection. Overcurrent protection is a 20 amp circuit breaker, it says. Lamp holders, any type. Receptacle ratings, 15 amps or 20 amps. And then permissible loads, it references me to Section B. And in Section B of 210.23b, that's where it tells me is for any cord and plug connected equipment, I would like to limit the load on that branch circuit to 80% of its rating. If it's equipment that's fixed in place, I want to limit my current flow to 50% of the rating on that circuit then. And that's a lot of stuff on Article 210. There's a lot of information in Article 210. So dive into Article 210 if you get involved in branch circuits. Make sure you understand them. Make sure you understand the applications and the requirements for wiring and sizing and receptacles and so forth. And the main thing then is that you work safe until we see you at the next Tech Talk.